Good evening, this is V. Sujit Babu from ECB section. Today my topic is about self-resetting LDR alarm from the subject linear IC applications. So let's look on to the introduction to light dependent resistors LDRs. And LDRs is a passive electronic component whose resistance decreases with increasing light intensity. It is made up of high resistance and semiconductors like calcium sulfide that responses to visible light in darkness. An LDR can have resistance over 1 mega ohm, and under the bright light it drops to a few hundred ohms. LDRs are widely used in automatic streetlights, camera exposure controls, and security systems. They provide a simple, low-cost way to detect ambient light levels without complex optics. And the principle of operation of an LDR: when photons strike the LDR material, they exit electrons from the variance and band to conduct the conduction of band. This increases the number of charge carriers, thereby reducing the overall resistance of the device. The relationship between resistance and light intensity is nonlinear and typically follows a power law curve. Responses the time is relatively slow, tense, and making LDRs unsuitable for high-speed applications. Despite the limitations, there are simplicity and reliability make them ideal for low-frequency sensing tasks. A basic LDR alarm uses the LDR in a voltage divider and configuration to produce a variable output and voltage based on light level, and the analog voltage is compared against the reference using a comparator IC such as LM311 or LM393. When light drops below the threshold, the comparator output triggers an alarm like buzzer or LED. The circuit typically includes hysteresis to prevent rapid toggling near the threshold voltage points. Power supply requirements are minimal, often operating from a signal 5 to 12 DC volt source. Traditionally, need for self-resetting functionality. Traditional alarms remain active until the manual resets, which is impractical in unattended or remote systems. A self-resetting alarm automatically returns to standby mode once the triggering condition is removed. This feature is improved. This feature is improved. This feature is improved. This feature is improves accessibility in applications like intrusion detection or automated light controls. It reduces false alarms and enhances system reliability without human intervention. Implementation requires integrating timing or feedback mechanism into the control logic. Circuit design and core components. Key components include in LDR fixed resistors, comparator ICs, IC timers like 555 output device, buzzer, LED. The voltage divider converts light intensity into measurable voltage signal fed the comparator inverting input. The potentiometer sets the reference voltage at the non-inverting input, allowing the adjustable sensitivity. The 555 timer is configured in monostable mode to generate a fixed duration pulse upon trigger. This pulse drives the alarm into enables the automatic deactivation after the preset time. Comparator comparator stage and threshold detection. The comparator continuously monitors the voltage from LDR resistor divider network. When ambient light falls below the set threshold, the LDR resistance rises, increasing its voltage sharing. Once the voltage exits the reference, the comparator output switches from low to high. The transistor acts as the trigger signal for the next stage. Typically, the monostable timer hysteresis via positive feedback prevents noise-induced false triggering near the threshold. Monostable 555 timer configuration. The 555 IC is wide monostable mode, producing A single output and pulse of fixed duration when triggered. Pulse with T is determined by external resistor and capacitor. T equal to 1.1 R into C into. This formula allows precise timing control. For example, R equals to 100 kilo ohms, C equals to 10 μF, and gives T equals to 1.1 second. During this period, the alarm remains active regardless of changing light conditions. After the pulse ends, the circuit resets automatically, returning to monitoring modes. Output stage alarm activation. The output of the 555 drives a transistor to switch higher current loads. This allows the control devices such as so, P, piezoelectric buzzers, LEDs, or relays for external indicators. A flyback diode is often placed across the inductive loads like buzzers to protect the transistor from voltage spikes. LED indicators can show both alarm state and power on status for user feedback. The entire output stage is designed to be low power, suitable for battery operated applications. Self-resetting reset mechanism explained. Self-resetting is achieved through the monostable actions of the 555 timer, which is inherently returns to ideal after one pulse. No additional reset with reset switch or microcontroller is needed, keeping the design simple and cost effective. If the light condition retrieves to normal during the alarm period, the alarm still completes its full duration. This ensures a consistent response time and avoids premature silencing due to the transient changes. For repeated triggers, the circuit must fully reset before accepting a new input signal. Practical examples. Imagine a beam of light interrupted by a person passing through a doorway. This breaks illumination of the LDR. On the LDR, the sudden drop in the light triggers the comparator, activating the 555 timer and sounding a 3-second buzzer. Even if the person have immediately, the alarm sound of for full duration is set by RC values. After 3 seconds, the system resets, resumes monitoring, ready for the next event. The behavior is ideal for security applications where brief instructions must be reliable, logged. Design considerations and trade-offs. Response: the time dependence on earlier characteristics low than photodiodes, but the sufficient for most alarm uses. Ambient light variations required adjustable threshold via potentiometers tuning. Power and consumption should be minimized for battery operations. CMOS comparators and low duty cycle designs helps. Environmental factors like temperature can affect LDR performance through usually within the acceptable limits. Mechanical shielding may be needed to prevent false triggers and uninterrupted light sources. Application in real world systems used in automatic night lights that runs on when the darkness is detected and reset set down. Integrator is an anti-theft device for cabinets or drawers, and the sound when opened in low light. The employed in industrial automation for detecting object presence via shadow interruption, suitable for educational kits and demonstrating sensors based feedback and timing. Circuits can be extended with relays to control external loads like lights, motors, or notification systems. Advantages and limits. Advantages include simplicity, low cost, no software needed, and reliable analog operation. The self-resetting features enhances the autonomy and reduces maintenance requirements. LDRs are robust, have no moving parts, and function well in moderate environment conditions. Limitations include slow response and susceptibility to ambient light interference and nonlinear response, not suitable for high speed precision and application requiring photodiodes or phototransistors. Thank you. Thank you.